All right, so the question was, could we do a problem like the absolute value of some imaginary stuff? So when I'm talking about the absolute value of a complex number like a plus bi, it is the square root of just the a coefficient squared plus just my b coefficient squared. So let's pick some values. So let's do the first example as 1 plus 2i. So here's going to be the square root of 1 squared plus 2 squared, which is going to give me the square root of 1 plus 4, which is the square root of 5. And I'm done. If I change the numbers up a little bit, and I did 2 minus 3i, an example for this one would look like 2 squared plus negative 3 squared. Again, we're always squaring these values, so they're always going to be positive no matter what. If it was positive, it's going to be positive. If it's negative, it's going to be positive now.
What's this type of question called again?
This is finding the absolute value of complex numbers.
Okay.
You want some more examples, or do you feel good with this?
I'm good.
Good? Okay, cool. What else we got? Can I go over 1A and B from the quiz yesterday? Yeah, absolutely. So let's look at the quiz. Let's see here. Oh, I'm actually going to grab the student version because I don't want all the answers on here. 9/11 group quiz, yep. All right, let's start with number 1, A and B. I should, in theory, be able to do this fairly well because I'm given a, whoopsie. Oh, please, computer, don't do me like this. There we go. All right, so the first one says fill in the t-chart for x and y values, and then also just graph the thing on the left using the middle point, aka the vertex, and moving 1 point out at a time from there. So here's where we want to kind of like do the thing where we scoot to the left, scoot to the right. So let's start here with looking at this thing. So what form does this appear to be in? So right now it appears to look like a little bit of a mess. So here I have a 3 hanging out, and here I have a 3 hanging out. And those are like terms, so I'm just going to add them up. So this equation should look like -2, and then I've got my x plus 3 squared plus 6. Cool. So from here, what form does it look like? It looks to me to be in vertex form. Vertex form looks like y equals a x minus h squared plus k. And the reason I say that is I see x plus or minus a value being squared here. And so let's talk about what our hk values are. H here, which is the tricky one, is -3, always opposite the way that it looks. And then my k value is 6. So now I've got my hk value, I know my vertex, because my vertex is hk. So -3, not a great negative sign. There we go. That's going to be the middle of my graph. So here's -3, 6. And now from here, I'm going to go to the left, to the right. So -4, -5, and -2, -1. Now I'm just taking these values and plugging them in. Hopefully we're able to plug in values all right. I can do one of these out if you'd like to see it out. But these are the points we should get. Does anybody want to see me do one of these? Basically, I'm taking this number and I'm plugging it into this equation, right? So I'm plugging it into my x value in this equation. So plugging it in right here to see what I get. You can plug it in here. You can plug it in here. It doesn't matter. They're literally the same thing. So I've just rewritten it the way that it's kind of meant to be with my terms combined here. So now I graph this thing. So graph it in purple here. So -3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So I got a point here. Why is drawing points the hardest thing with this? There we go. And then I'm going to go to my next point here and here. And then my next point here and here. From here, I just connect my dots. Whoa. There we go. My parabola. Any questions on 1A? Perfect. Let's take a peek at 1B. So starting out here, I kind of want to see what form this is in, and maybe I can clean this up a little bit. So I see in my parentheses, I have 1 plus x plus 1. Well, that to me looks like I could just call this thing x plus 2. And then I've got this bit over here, which looks like x minus 4. And I've got this bit on the outside, which is plus 3. Is this in intercept form? No, it is not, right? I've got this plus 3 hanging out on the outside here. For 1B, missing the numbers, it just said plus 3 in the document. I had a couple people said they had trouble with the document. Most did not, but the issue stems from Microsoft Word having an equation editor, and this part, if I remember correctly, is in equations editor. And so basically what happens is that sometimes Google Docs will lose that. So the plus 3 on the outside looks like something I'd written like separately. So to avoid that, we can just use a desktop. I'm trying to think of the workaround if you don't have a desktop. There's just going to be some formatting issues, and it is what it is. But this is being a Microsoft document will sometimes get screwed up by Google Docs. So I apologize for anyone who had issues with that. I'll continue doing the problem. Just keep in mind that when you guys are taking the test, it's going to be the same format. So if it didn't show up like that before, I don't know. I might have to then, take pictures for you guys of each page. How many of you guys had that issue?
I did.
I did too. It just it confused me.
So a lot of people did. Okay.
Yeah, there was an entire section that was just not even there.
First section wasn't there. Okay. So I guess what I'll have to do is upload pictures. All right. Just write myself a note to do that. Just more remote learning fun. So looking at this now, I've got that this thing does not look like intercept form because it's got this extra little, plus whatever on the end. And so when I look at this thing, I say, okay, well, I need this in some form that I can work with. I can always get my thing into standard form. So let's take this thing and turn it into standard form. So what I'm going to be doing is foiling these two things. So this gives me x squared, and I get my outside part, which gives me minus 4x, my inside part, which gives me plus 2x, and then I get minus 8, and I get plus 3. So again, my outside, inside last here. And so now as I look at this, I'm just going to add my like terms. So I get x squared minus 2x minus 5. So from here, this looks like it's in standard form. Standard form says I can do negative b divided by 2a, and that'll give me my x for my vertex. So for us, this is going to look like negative of negative 2 divided by 2 times 1, which is just 1. So my vertex for this thing is 1. And then from there, again, 2 to the left, 2 to the right. So 0, negative 1, 2, and 3. When I plug in 1, what does it spit out? So this is where we're literally just going to be plugging in values. So if I plug in 1 here, I'll write one of them out just to show you guys how it looks. You can go back to the original or back to our simplified version, or you can go back to this version here. I'm just going to do it in this version here because why not? If you want to plug it in, this is fine. If you want to plug it in, this is fine. So x squared here is just going to give me 1 squared minus 2 times 1 minus 5. Whoops. There we go. So here I get 1 minus 2 minus 5. So this is going to end up being negative 6. So I get my first point at 1, negative 6. And then I just plot the rest from there. So this is going to be negative 5. This is going to be negative 2, negative 5, and negative 2. Again, just plugging those points in, and these should match up because it's going to be reflected symmetrically. I think I'm something like this.
Mr. Goldenberg.
Yeah.
When you plugged in for the GX side,
yep,
and you were plugging in 1 to the second at minus 2 times 1 minus 5 equals negative 6.
Yep.
What were you plugging in 1 for in that equation?
The x value.
So you were taking the original equation?
So you could do it with the original, you could do it with this cleaned up one, or you could do it with this one here. They're all the same, just looking slightly different.
Right.
So I chose to plug it in here, but you're more than welcome to plug it in here or here as well. You could even plug it in here if you wanted to.
All right.
Good question. Oops, kind of missed there. Any other questions on this one? Cool. All right. So definitely going to be some difficulties there if the quiz didn't load up right for you. The next one was 9 and then 11. So here we are looking at, okay, I've got y equals all this junk plus some value here, and I want to write it in vertex form. So to get this thing in vertex form, it's going to look like y equals, and then that whole thing where we've got a times x minus h squared plus k. So now that I go through and do this part here, I'm going to say, all right, well, if I want to get it to look like vertex form, I'm probably going to have to go through and figure out what first and foremost this thing is. So as it looks right now, it looks like I've got some sort of combination of, you know, a couple binomials being multiplied, and then I've got this like 3 hanging out on the outside. So let's actually go through and multiply this, FOIL it out. So the first thing I get is x squared plus 19x plus 3x plus, what do we get, 57? Plus 3. So this part here comes from foiling these two things out. And now I'm going to combine my like terms, so I end up getting x squared plus 22x plus 60. So now from here, I want to say, okay, well, I actually want this thing to look like my standard form, my vertex form, so I want to complete my square. This 60 is not what I want. What I want is going to be based off my b value. My b value here is 22. So what I'm going to do is 22 divided by 2, and then I square that thing. So I get 121. That's what I want. So I'm going to rewrite this thing as x squared plus 22x plus 121 minus 121. Again, here's my clever 0, and I still have this plus 60 hanging out on the outside. So again, this is all just y equals still. So now these first 3 terms, by design, are going to be my binomial square. This is my perfect square trinomial that I just made by taking my b value, dividing it by 2, and squaring it. So here it's going to be x plus, and it's always just 1/2 the b value, so x plus 11 squared. And then on the outside, what's happening? I have negative 121 and a positive 60. So this is going to be minus 61. Just like that, I am good to go. Any questions here? A value here is just 1.
Our test will be on Monday, right?
Correct, yep. Yeah, there's no class tomorrow. You guys have a teacher workshop day.
So how's this gonna go? Like, will it be a Google Forms? Will you just post the test and we solve it and then we upload pictures?
Yep, so I'm going to post the test. Apparently I have to go through and take pictures of it as well, and I'll upload that as well. But it's going to appear when class starts. So if you're late to class, it just means you're going to get less time on the test because it's going to be due when it's due. There's no exceptions there. So it's going to open up at it's going to open up at approximately 9:45, but give it a couple minutes, so like all the way up till like 9:48, and you'll see an assignment appear for you, and then it'll be due at 11:09. So you can either download it and write your answers in it, you can print it off and write your answers there, or you can very clearly write your answers in a notebook or paper or whatever, and then upload that when you're done. Just set a timer for yourself because again, it's due at the end of the block.
Okay. Thank you.
Yeah, I'll take pictures of the quiz as well, and I'll upload those. So this was number 9. Let's check out number 11. Every time. All right. So here we are looking at graphing a system of inequalities, okay? So quadratic inequalities, again, maybe it looks like a curve. For inequalities, maybe it looks like a line. This thing here, to me, whoops, looks like it's going to be a curve, and it looks like it's in vertex form. This thing looks like it's going to be a line, and it looks like it's going to be horizontal. So let's do the red one first, as this is like the more difficult part, I would say. This is in vertex form. It's also in standard form. So whichever way you want to approach it, I'm going to say my vertex for this thing oops, is 0, -4. And then in terms of my points, I'm just going to, again, set up my t-chart. So x's and y's start out in the middle here at 0, -4. I'm going to space out, so I'm going to go -1, -2, 1, and 2. I'm going to plug in some points. So when I plug in my points, it should give me -3 and then 0, -3 and then 0. And then from here, I'm able to graph this thing. So let's do this in red. So when I'm doing this, I've got, what, 0, -4, 1, 2, 3, 4. And I'm going to put a point here. And I'll talk about how I'm going to draw this thing in a second. So first of all, there's a point. Here's a point. And then here's another point. And I'll want to be able to see all those points clearly. From here, is this going to be bolded or dotted? Since this is strictly greater than, this is going to be dotted. So I'm going to try my best here to draw a dashed line. Again, part of the instructions say, you know, if it's not looking clear to you, then you can like label it and you can just say, you know, Mr. G, this is a dotted curve here. So now once I've got the dotted part done, I want to say y is greater than that value. If y is greater than this thing, means I'm going to be shading above. So I want to be shading something like this, and I'm not going to go crazy with the shading quite yet because I'm not done my problem. The second half of this problem says y is going to be less than or equal to 2. This is the stuff we did before. So y equals anything is going to be a horizontal line. So here my horizontal line is going to be at 2, and here it's going to be bold. And the reason why it's bold is because it's it's less than or equal to. So here's my horizontal line there, and I want to shade below this thing. All right. So now I've represented the information for both of my graphs. Where's my common bounded region? So now I'm going to be shading where I'm below the green and where I'm above the red. And it should look something like that. Any questions here?
How did you get the vertex points?
The vertex
Again.
comes from this as being in vertex form. So this is already in vertex form, and I can get my vertex that way. But if I don't identify that, I could treat it as if it were in standard form. If I were talking about standard form, my a value equals 1. My b value, since I don't see an x, is 0. And my c value is -4.
Okay.
Good question. What else we got? Cool. Let's see if there are any more in the chat here. All right. Guys, got anything else for me? Alrighty, so it looks like we are almost good to go here. Fun intermission. 10 out of 10, would recommend. 5 stars on Yelp. Please work this time. Fingers crossed. Drum roll works. We're good. So let's look at 2C, which was the question 20 minutes ago before everything crashed. So we will grab this thing. And then go to Paint. And we make it what we want. And we're good to go. All right. So for 2C here, when we're looking at factoring this polynomial, I want to first look at, is there any common terms between them? So is there anything common between 100x squared and 49w squared? Unfortunately not. So now I just go to my next step, which is to look at this thing and I think, okay, well, maybe I can factor this, but before I even want to start to get into factoring, I just look at it and say, okay, well, 100x squared looks kind of familiar to me, and 49w squared looks kind of familiar to me. These both look like squares respectively. So 100, whoopsie, let's make this a little bigger. So 100x squared looks to me like I have, 10x being squared. and I've got that subtract, and here I've got 7w being squared. And what's special about that? So the thing that's special about that is this looks to me now I have a squared minus a b squared, and what is that? That's my difference of two squares. My difference of two squares will always factor into a plus the thing, and then my a minus the thing. So when I'm looking at my difference of two squares here, for this problem, it's going to end up being 10x plus 7w, whoa, kind of a weird w, and then times 10x minus 7w. And I'm done. Just my difference of two squares. Let's do 6c. So looking at this one here, I just want to be able to simplify and put this in standard form. So standard form should look like a plus bi. So the constant thing and then plus whatever i's I get. So here I've got 5 times whatever's going on here. I'm just going to write my 5 on the outside of this stuff. And I'm going to do this stuff first. So here I'm going to FOIL this out. If you wanted to distribute your 5 into one of these, you could. So if you wanted to make this 10 plus 15i, boom, that's fine. You distributed it once. If you take the 5 and put it into this thing, and you put it into this thing, you've double distributed, and that's not a thing. So here it's just like saying I have 5 times 2 times 3, right? I don't do 5 times 2 and then 5 times 3. It's just 5 times 2 times 3 is 30. So when I look at this, I'm saying, okay, well, I've got 8, and now I'm going to say my outside term is going to be negative 18i, whoops. And then I've got my inside term, which is going to be plus 12i. And then my last term is going to be minus 27i squared. Now still have the 5 on the outside of this thing. So as my next step here, I'm going to start combining my like terms. 8's going to kind of stay an 8. Here I've got negative 18i and a positive 12i, so this should be minus 6i. And then over here I've got minus 27i squared. What is I squared? I squared is negative 1. So whenever I see, whoops, man, I'm not very good at doing the negatives. There we go, negative 1. So when I see an I squared, I'm just going to exchange it with a negative 1. I should never see I squared in my answer. So this used to be minus 27i squared. Now it's just going to be plus 27. So again, it's just going to change the sign because it's times negative 1. So we'll add these things up. So I get 27 plus 8 gives me 35. Minus my 6i. And then from here, I'm going to do my distributive property into it. So now I'm going to say this is, we got 175 minus 30i. And I'm done. Let's look at 10. Any questions here? All right, 10b it is. All right, let's see. Getting a little parched here from all this educating. So when we're looking at 10b here, I'm saying, okay, well, I want to find the discriminant, and I want to solve for the x value, and I want to use the quadratic equation to do so. To do the quadratic equation, I first have to know what it is. So my quadratic equation is that whole negative b plus or minus square root of b squared all over 4, or excuse me, plus or minus b squared minus 4ac all divided by 2a thing, which I will write down. So it's going to be, well, let's actually start out what it needs to look like first. So it needs to look like a x squared plus bx plus c equals 0, right? We have to set it equal to start. That's the first thing. And then I'm able to solve for my x values as saying x is going to equal negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And so now I'm going to solve this by first getting it set equal to 0. So I'm going to add 1 and I'm going to add 9x. So I'm going to do this to both sides of my equation. So now I've got something that looks like x squared plus 18x plus 81 equals 0. So now I want to get my a, b, and c values. So now I've got it set equal to 0. I get my a value here is 1. My b value is 18. And my c value is 81. So now I can take these and plug them into my equation here. So let's get it set up as negative 18 plus or minus square root of 18 squared minus 4 times 1 times 81 all divided by 2 times 1. Do some simplifying mathematics here. So we got 18 squared is 324, and then I believe 4 times 81 is also 324. Wowie. Negative 18 plus or minus, I'll just write this out one time, whoopsie. 324 minus 324, all divided by 2. So this just ends up giving me 0. So I have negative 18 plus or minus 0 over 2, which is just negative 18 over 2, which is just negative 9. So my answer here for this one is going to be negative 9. And let's talk about what the discriminant is. The discriminant is just this part here. It is just b squared minus 4ac. So that is my discriminant. What did we get for the discriminant down here? We got 0. Okay, so I mean I can write square root 0 here if we want, but this thing on the inside gave me 0. And we know that when our discriminant is 0, we'll have one real answer. If my discriminant is positive, I'll have 2 real answers. And if my discriminant is negative, I'll have 2 imaginary answers.